Good morning, friends. I welcome you to this lesson. It is a continuation from where we stopped last time. We looked at the mode, but I want to resume from that point how to compute the mode of a grouped frequency distribution. We saw how we can compute the mode for a simple frequency distribution, and then how to compute the mode of an individual observation. So let's try to look at how we can find the mode when it comes to a grouped frequency distribution. So when we talk about the mode, just a review to try and remember. So the mode is basically that value that has the highest frequency. So when we talk about the mode, the number of times an event occurs determines the mode. So for a grouped frequency distribution, the mode is given by the formula below. So this is the formula that we use when it comes to finding of the mode of the grouped data. So we have mode is given as LB, where LB is the lower class boundary of the model class. Lower class boundary of the model class. Then D1 is the difference between the model frequency and the frequency of the class before the model frequency. Then D2 is the difference between the frequency of the model class and the frequency of the class after that model class. Then of course we talked of CW. CW is the class width. So the class width is given as the difference between the upper class boundary and the lower class boundary. So that difference between the upper class boundary and the lower class boundary gives us what we call the class width, or we can call it the class interval. So without wasting of time, we can move on to look at an example. So we have an example that says the example says determine the mode of the frequency distribution depicted below. So we have a class interval of 5 to 9, 10 to 14, 15 to 19, 20 to 24, 25 to 29. We've adjusted this step a bit. So the classes, we change them to, the classes are from 10 to 20, 20 to 30, 30 to 40, 40 to 50, and then 50 to 60. The question wants us to find the mode. Remember, we said the mode is given by that class having the highest frequency when it comes to grouped data. Now, first of all, we need to tell the model class. Which one would be the model class? We simply look at the frequencies. So you have frequencies of 2, 9, 15, 20, and 4. And you find that 20 happens to be the highest frequency. So the class corresponding to that frequency of 20 is what we take to be the model class. So meaning our model class is a class of 40 to 50. That is the model class. The reason being it has the highest frequency of 20. So now let's try to move on to see how we can compute the mode of this data. So you can copy our formula. So the mode is given by LB plus D1 over D1 plus D2 times the class width. So having already determined our model class, so we can move on to find our mode. So our mode would be given as, so the lower class boundary is 40 and the upper class boundary is 50. Now the formula wants us to use the lower class boundary. Remember, these are exclusives. For an exclusive kind of data, class limits act as boundaries. So in this particular class, which we consider to be the model class, the lower boundary is 40. So we shall have 40 plus 40 plus. Now D1, what is D1? We say D1 is the difference between the model frequency and the frequency of the class before. Now if the model frequency is 20, then the frequency of the class before that model frequency is 15. If the model frequency is 20, then the frequency of the class before is 15. Now the difference between 20 and 15 is what we take to be the D1. Then our D2 is the difference between the model frequency, that is the frequency of the model class, and the frequency of the class after the model class. So the class after the model class is 4. So meaning D2 will be the difference between 20 and 4. minus 4. And then CW is the class width. So the class width is given as the difference between the upper class boundary. So CW is given as upper class boundary minus lower class boundary. So upper class boundary minus lower class boundary. So now in this, if we look at our model class of 40 to 50, the upper class boundary is 50 and the lower class boundary is 40. So we can find the class width, that is 50 minus 40. So the difference would give us a what? The difference would give us the class width. So you can now proceed and find the differences. So 20 minus 15 we get a difference of 5. 20 minus 15 we get a difference of 5. So maybe I can get my calculator so that we can move together. So 20 minus 15 we get 5. So this would also be 5. D1 is 5. And then the difference between 20 and 4 is 16. That is now D2. So 20 minus 4 we get 16. And then now the difference between 50 and 40, that is the class width, is 10. So you can as well confirm here. 50 minus 40 we get a difference of 10. So our class width is 10. So let's work this out to find the mode. So our mode will be 40 plus so now let's find the summation of the denominator, that is now 5 plus 16 giving us 21. So 21, 5 over 21 times 10. So proceed. So our mode would be 40 plus 5 over 21, that is 5, divided by 21. times 10, we get 2.3. We get 2.38. So implying that our mode will now be 40 plus 2.38. 40 plus 2.38 will give us 42.38, and this will be our mode. So our mode will be 42.38. So since we are not given the units, so we can leave it as that, 42.38. That is our mode, and that is how we compute the mode. So when you look at this formula, you realize that we first deal with the brackets. So we try to follow the body mass. So whereby we first deal with the brackets, and then multiplication, and then addition comes last. So that is why we first solved the brackets, and then we finally added the 2.38 to 40. So there we are. So now let's proceed. So that is basically how we compute the mode of a grouped frequency distribution. So of course we looked at how to compute the mode for the other kinds of data. Now we are done with looking at how to compute the mode when it comes to a grouped frequency distribution. So now let's look at another variable, and now that is the median. Now when we talk about the median, simply we mean that variable that divides a distribution into two equal parts. The value that divides the distribution into two equal parts is what we take to be the median. So according to this, we are told that this is that value. This is that value which divides the data set into two equal halves. That is 50% of the values lying below the median and 50% of the values lying above the median. So the approach we consider below uses arithmetical methods for estimating the median value for both grouped and ungrouped data. So still, when we talk about the median, we are going to find the median for two sets of data. Basically, that is grouped data, ungrouped data, specifically individual observations, as well as simple frequency distributions. So we can begin right away with the median of individual observations. So now when you to to find the median of an individual observation, so what you do, you begin by arranging these values in ascending order. You arrange them in order. So the median is the number that appears in the middle of the observation. So however, to find the median of such observation, it requires you to arrange them in order, that is ascending order. Then the value that will appear in the middle will be the median value. So now we have an example that says find the median value. Find the median of the following observations. Find the median of the following observations. So the observations are 5, 10, 15, 3, and 2. So what we are going to do is to arrange these observations in order. We can arrange them in ascending order, and then we try to identify which value appears in between. So here we go. So given those values, the smallest is 2, and then the next is 3, the next is 5, the next is 10, the next is 15. The next is 15. So now we try to look at the value that appears in the middle. So now let's try to find that value that is in the middle. So we have this 2. We can cancel this against this. And then when we go to the next, we cancel 3 out. And then we also cancel 10 out. Now the value that is remaining in the middle is 5. And that automatically becomes our what? Our median, because it is the one left in the middle. So therefore the median value is 5. The median value is 5. The median value is 5. So that is in case the observations form an odd number. For example, now these are 5 observations. However, supposing you're given observations that are even in nature, that are even, for example, there are only 4, so it may be not directly for you to observe the value that will appear in the middle. Reason being, you have 2 values in the middle. Now assuming from this question we eliminate, let's form it into another example, and then we still find can call it example 2. Example 2. So find the median of the following observations. We have 5, 10, 15, and 3. So these are 4 observations. 1, 2, 3, 4. The other ones were 1, 2, 3, 4, 5. Now, what happens if you had to find the median of these observations? Of course, the criteria still remains the same. We have to arrange them in ascending order, and then identify the value or the values that appear in the middle. Then from there, the median would be an average of those values that do appear in the middle. So let's try to solve this. So we arrange. So the first value, the smallest, is 3. The next is 5. The next is 10. And finally, we have 15. Now, when you try to cancel this out, we cancel 3. This side we shall cancel 15. Then now you realize that we are going to be left with 2 values in the middle, and it is now from those 2 values in the middle that we shall have to derive our median, compute our median. So in this case, the median is going to be an average of those 2 values, 5 and 10. So median will be equals to so we have 5 plus 10 divided by 2, because there are 2, 5 and 10, there are 2 observations. That is why we divide them by 2. So this would give us so this would 5 plus 10 gives us 15. So now when we divide 15 by 2, when we divide 15 by 2, you can have a simple calculator here. So that is 15 divided by 2, we get 7.5. So our median in such a case would be 7.5. I hope we are clear with that. 7.5. 7.5. So in case of any question, so we shall ask at the end of the video, then we'll see how we can be guided in different ways for purposes of understanding what we've covered today. now let's proceed and look at the next category of data. So we've looked at the median for an individual observation. So now let's try to look at the median when it comes to simple frequency distributions. Median when it comes to simple frequency distributions. So when it comes to the median for a simple frequency distribution, that is basically ungrouped data still. So we have some procedures that we do follow in order to find the median value. So one is arrange the values in ascending order. So we must have these values arranged in a numerical order, that is particularly ascending. So then from that point we find the median position. We find the median position. What is our median position? So the median position is obtained by this formula, a half of n. Why do we use a half? We use a half because the median divides the distribution into two equal parts. A half of n, where n is the total number of observations, n is the total frequency. So then after we find the cumulative frequencies. So we'll create a column for cumulative frequencies. Find the cumulative frequencies. Then after finding the cumulative frequencies, the value the value that is equal or just greater than a half of n under the cumulative frequency column is what we read. And once we identify that value that is just equal to a half of n or greater than a half of n, the corresponding observation is what we read as the median value. So here we are told that the value corresponding to a half of n under the observations is the median value. So now let's try to apply these steps in an example to see how we can find the median value when it comes to a simple frequency distribution. So the example says, we have an example, and the example says the age of 50 people are given in the table measured to the nearest 1 inch. So the age of 50 people in the table measured to the nearest 1 inch. So we have age and then we have the number of persons. Of course, the number of persons is the same as the frequency. It's the same as the frequency. So as we said, the frequency is the number of times an event occurs. So meaning that we have our frequency and then we have the observations. So when you look at the observations, 62, 63, 64, 65, 66, 67, they are already in a chronological order. They are already in an ascending order. So that is okay. Then now we are going to find the frequencies those are the number of persons. And then now let's try to solve this. The question says find the median. Find the median. Let's try to solve for the median. So we can let so we are saying we let f to represent the number of persons That is basically the frequency. So now we can have a simple table. So we shall have the edge, we shall have the frequency, that is F, and then we shall have cumulative frequency. Cumulative frequency, you can call it CF. So you can enter these observations, the ages of these people. So the age we have 62, we have 63, we have 64, we have 65, we have 66, we have 60, 67. Then now we can enter the frequencies. So the frequencies under 62, we have 1, then we have 5, we have 12, we have 14, then we have 10 under 66, and then 6 under 67. Right. Now we are going to find the cumulative frequencies. So how do we find the cumulative frequencies? We simply keep on increasing the frequencies of respective observations. For example, the first cumulative frequency is the frequency of the first age, that is 62. Its frequency is 1. So we take that to be the first cumulative frequency. And then now to find the cumulative frequency of the next age, so we get the previous cumulative frequency of 1 plus, we're talking of this cumulative frequency, plus now the frequency of the next age group, that is 63. So now 1 plus the frequency of 5, so we get cumulative frequency of 6. Then we move on to the next. So to get the next cumulative frequency, we shall have the previous frequency of 6 plus the next frequency of 12, we get 18. Then to get the next cumulative frequency, we shall have the previous cumulative frequency of 18 plus the frequency of 14, we get 32. To get the cumulative frequency of 66, we get 32, which is the previous cumulative frequency, plus the frequency of 66, which is 10. We get 42. And then finally, to get the cumulative frequency of the last age bracket of 67 age group, we have the previous cumulative frequency of 42 plus now the new frequency of 6, we get 48. Then now we also come and find the total frequency. Come and find the total frequency. we find summation f. Now this summation f acts as our n because we need n to find the median position. So you can sum this up and obtain the total. So 1 plus 5 plus 12 plus 14 plus 10 plus 6. We get a total of 48. So our total frequency is 48. So thus summation f is the same as n is the same as 48. So meaning that our total frequency is 48. So now we are done with let's try to follow this to see the steps we've now so far moved. The first step was arranging them in ascending order. So we said the values were already in ascending order, as you observed: 62, 63, 64, 65 up to 67. So that was done. Then now the next step was to find the median position. So the median position, we're going to find the median position. So the median position is given as a half of n. Is given as a half of n so our n is 48. So a half of 48 is equivalent to, so 1 divided by 2 times 48, we get 24. So our median position is 24. The median position is 24. So we've managed to get the median position, and we also found our cumulative frequencies already. So now we have the cumulative frequency because we have another step that requires us to find the cumulative frequency. Find the cumulative frequencies. We have this cumulative frequency column already found here. So now what is going to be the next step after finding your median position and the cumulative frequencies obtained? Let's look at the next step, and then now the next step, that is step 4 rather. It says find the value equal or just greater than a half of n. So let's first stop at that point. Find the value equal or just greater than a half of n. Let's first work on that. Now when you come to our workings under the cumulative frequency column, remember our median position, or what we take to be a half of n, is 24. Our median position is 24. That is the half of n. So come under the cumulative frequency column here, this column here. Can I write it? Then I will look for 24. If we have 24 appearing there, we read that 24. However, in most cases, you may not find the exact value equal to the median position. So that's why the statement says find the value equal or just greater than the median position. Now our median position, or a half of n, is 24. If you find that 24 does not belong to this column or is not indicated in this column of cumulative frequency, then we take the cumulative frequency just greater than 24. So the value just greater than 24 along this cumulative frequency column is 32. So meaning that from 24 you go to 32 according to this cumulative frequency column. But remember, 24 is not there. Supposing this was 24, let's say, supposing this was 24, then it would mean we would automatically take this, read it as the value equal to the median position, or a half of n. So take it. But if it happens not to be there, you take the cumulative frequency just greater than 24, and that is 32. That is why we've chosen 32, since 24 is not there, and instead we are given 32 in the column. So we take 32, which is the one which is just greater. So now the first priority is you give equal. The first priority is you consider a value equal to what you're looking for, to a half of n. But in case you find that there is no value along the cumulative frequency column equal to what you're looking for, in particular this time you're looking at 24 as our median position, then now you come and take this value just greater than 24, or just greater than a half of n. That is in case you don't find the one equal. But if it is there, take it right away. Don't go for the just greater. If the equal is not there, then take the one which is just greater than a half of n. Now the value corresponding to a half of n, or the value corresponding to a half of n, or just greater than a half of n, or just greater than a half of n under the observations is the median value. Under the observations is the median value. Now we go back to our cumulative frequency column. Now that we found the just greater than value, that is the 32, so the corresponding edge is the median value. So in this case the corresponding edge is 65. So meaning the median edge is 65. The median edge is 65. So that is how we find that median when it comes to simple frequency distributions. So we can come and say therefore the median edge is 65 yards. The median edge is 65 yards. So that is how we simply find the median when it comes to simple frequency distributions. Then now we can look at the last segment when it comes to median computations, and that is basically the median for grouped data. And that is basically the median for grouped data. How do we find the median for grouped data? The median for grouped frequency distributions. So under that right hand side, the median of a grouped frequency distribution is computed using the formula below. So we have LB. LB is the lower class boundary of the median class. LB is the lower class boundary of the median class. Then plus a half of n. Of course, n is the total frequency. N is the total frequency minus CFB. Now, CFB is the cumulative frequency before the median class. The cumulative frequency before the median class. And then FM is the frequency of the median class. FM is the frequency of the median class. FM is the frequency of the median class. Then whereas CW is the class width. CW is the class width. So we said LB is the lower class boundary of the median class. N is the total frequency. CFB is the cumulative frequency before the median class. CW is the class width, and FM is the frequency of the median class. So you find that if you have to solve a question, or if you have to find the median of a given distribution, especially grouped data, you need to begin by finding the median class, because everything rotates around the median class. So let's try to look at an example. So let's look at an example. So the example says the recovery time of an aircraft, which is the time that elapses between its arrival at the airport and its being ready to take off again, is given below for several aircrafts. So we have the recovery time, that is 10 to 15, 15 to 20, 20 to 25, 25 to 30, and then 30 to 35. The frequencies, or the number of aircrafts that can arrive and get ready to take off again within those time intervals, are given as 3, 11, 13, 21, and 26 aircrafts. So the question is, calculate the median recovery time. Calculate the median recovery time. So now what we are going to do, we are going to create a table, to form a table of this information. Then we shall find the frequencies. Then we shall as well find the cumulative frequencies. Now the cumulative frequency column will help us in finding the median class. Then from there we shall be able to make computations. Then we shall need also to find the median position, and that is a half of n. A half of n. So let's try to move on with this slowly. So let's have a table. So we shall have the recovery time, then we shall have the frequency, and then we shall have the cumulative frequency. So we have recovery time of 10 to 15. Its frequency is 3. Then we have 15 to 20. The frequency is 11. Then Then we do have 20 to 25. The frequency is 13. Then we have 25 to 30. The frequency is 21. Then we have 30 to 35. The frequency is 26. Okay, so now that this is what we have. So then now we find the cumulative frequencies. We can accumulate these frequencies. We find the cumulative frequencies. The first cumulative frequency will be 3. Then now the next cumulative frequency will be 3 plus the next frequency of 11. So which is 14. So to get this cumulative frequency of 14, we get 11. We get 3 plus 11. So meaning to get the cumulative frequency of 20 to 25, we shall have the previous cumulative frequency plus the next frequency of 13. So meaning we shall have 14 plus 13, giving us 27. Then now to get the next frequency, cumulative frequency, we shall have the previous cumulative frequency of 27 plus the next frequency of 21. So meaning we shall have 27 plus 21, giving us 48. Then now to find the next cumulative frequency, we shall have the previous cumulative frequency of 48 plus the next frequency of 26, and this would give us the next cumulative frequency, 48 plus 26, giving us 74. So we can also find the total cumulative frequency because we need it. Total cumulative frequency, not total cumulative frequency but total frequency. To can sum this up, we have 3 plus 11 plus 13 plus 21 plus 26. We get 74. So our total frequency is 24. Now we need to find the median position. So we need to find the median position to help us in finding the median class. So the median position is given as a half of n. It is given as a half of n. A half of n so of course our n is equivalent to the total frequency, so meaning that we shall have a half of 74. So half of 74 So 1 divided by 2 times 74, we get 37. A half of 74 is 37. Now this 37 is necessary for purposes of finding the median class, because without the median class we shall not be able to calculate the median. We need to first have the median class. So now we come to the cumulative frequency column now to look for 37. If we happen not to find 37, we take the cumulative frequency just greater than 37, and that cumulative frequency just greater than 37 is the one that gives us the median class. The corresponding class becomes the median class. Now let's try to look for 37. Now when you come to this column, the cumulative frequency column, we do not have 37 catered for. So what we do, we take the cumulative frequency just greater than 37. So we find that from 27 we come to 48. 37 is not there. So meaning the cumulative frequency just greater than 37 is 48. And therefore the class to which 48 corresponds is our median class. What does this imply? It implies that our median class is that class of 25 to 30. Now we are able to calculate our median value. So therefore the median is computed as follows. So let's find our formula. So this is the formula for finding the median. So now let's simply substitute the variables accordingly. So now the lower class boundary of the median class, just as we've identified it, the class of 25 to 30. So the lower boundary is 25. And then a half of n is already computed, that is 37 minus the cumulative frequency before. So the cumulative frequency before now if this is the median class, the one of 25 to 27, then the cumulative frequency before the median class is 27. So we pick out 27. And then the frequency of the median class, so if this is our median class of 25 to 30, the frequency is 21. The frequency is 21. So we read 21. And then the class width of that class, as we said, is the difference between the upper class boundary and the lower class boundary. So the upper class is 30, the lower is 25. So the difference between 30 and 25 is the class width. As you can observe, 25 to 30. So the difference between those two limits or boundaries is the class width. Now let's proceed and then work it out. So So shall have 25. So the difference in the numerator, that is 37 minus 27. That is a difference of 10. So we have 10 divided by 21 times, now the difference between that and 25 is 5. So times 5. So now work out this and then finally we'll add. So shall have 10 divided by 21 is 0.47 times 5, giving us 2.38. So it's implying that our median would be 25 plus 2.38, giving us 27.38 minutes. So our median is obtained as 27.38 minutes because the recovery time is in terms of minutes. So with that, we come to the end of today's session. So I would like to thank you for attending this class. Please don't forget to subscribe to the channel because most of our classes may be conducted through that channel. So you need to subscribe and then tap the bells, in that whenever a new video is uploaded, you can be notified about that, for simplicity in following up what is moving on or what we are currently doing. So thank you so much. Alex Okero. So we'll meet in our next lesson. Ciao ciao.